Hello, everyone. So, today we are going to start getting deeper into the computer science aspects. So, we are going to be getting into programming today. So, we are going to pretty much get an idea of what programming is and how it is done. So, first, let's talk about what is a program. So, a program is basically just some instructions that you give your computer. And many times these programs are written by a human and they are given to the computer to do a specific task. Now, in order to deliver this program to the computer, you would have to use some sort of programming language. Now, I did mention that there are different types of programming language. You got your low level and you got your high level. And your low levels are closer to, your computer language, while your high levels have a longer process to get down to the computer language. But in the end, regardless of what programming language you use, all programming languages are converted to binary for your computer to understand how to complete that set of instructions. So basically, just kind of think of your program as a recipe for the computer. The program has to be followed step by step for it to be able to do whatever result you are asking it to do. So, again, an important note is when you're speaking to a computer, you can use various different programming languages, and we will cover those here. So, a programming language is how you can write your instructions to the computer. Again, there are various types of programming languages, which we will cover. But the one important thing you need to know is that each language is going to have its own syntax. And syntax is another word for rules. So, basically, each programming language has a set of rules you need to follow when you are writing that language for it to work. If you do not follow the syntax or the rules, you may have issues or it may not work properly. So that is why following the syntax is very important. So here are some example of programming languages. Um, Python, Java, C, C++, C Sharp. Yes, they all have the same C part, but they are different. The syntax is different, so they have different rules. You have Ruby, PHP, Swift, R, and JavaScript. So, for example, Swift is actually for your Apple products, so creating iOS apps or Mac OS apps. Um, and Many people aren't necessarily in the Swift world of things unless you are into Apple devices, but I just wanted to throw that in there for anyone who may be interested in getting into like iOS app development. That would be how you would learn that. But overall, these are some popular programming languages. Now, is this the complete list of all programming languages? No, but these are some that are used fairly often in the industry. So, these programming languages can be found in different categories or placed in different categories, I should say. So, there are these different types of programming languages: procedural, object oriented, functional, scripting, markup, and query. Now, we are going to deep dive a little further into each of these so you kind of get an idea of the difference between them all. So, the first one, procedural. So, your procedural languages are the ones that you use step by step, or you have functions to accomplish the task. So, just to give you an idea, a function is just a grouping of program code that you can call one line of code to call 50 lines of code. So, it's basically like putting 50 lines of code into a box, and all you have to do is pick up that one box or use that one box instead of picking up 50 individual things. So that's a short, brief intro into functions. So your procedurals would be like C, C++, or Java. Really, A lot of programming languages can technically fall in the procedural languages category because in many cases, uh, a programmer is writing the code step by step to accomplish some goal. So these are some examples of well-known languages that people would definitely categorize as procedural. But again, some other programming languages can fall under this as well. So object-oriented languages are a very common one nowadays. And many times with these languages, you would organize the program into objects. And these objects will have properties and behaviors. So when I say objects, I'm literally meaning like a literal object. So, for example, you could create a program that is going to be like a program about animals. So your object would be an animal. But then you could have an object that is a cat. You can have an object that is a dog. You can have an object that is a bird. And each of these objects are going to have different properties. So, for example, your cats and your dogs are going to have four legs, while your birds are going to have two. Um, you could have different colors of the animal. You can have different ages of the animal, different living environments of the animal. So they will have different properties. You can also have different behaviors. So what is it that animal is going to do? For example, your dog is going to bark, while your cat is going to purr, while your bird is going to chirp. So the objects are used to organize based on what the object is. So each object has its own properties and has its own different behaviors, but they can all live within the same area or the same program, for example. And object oriented languages are really used to encourage reuse of code. So, again, if you have an object, you might have a program that you want to have information about various different dogs. And if that's the case, you can reuse the dog object to pretty much just update the properties and behaviors to whatever that dog has. So that is just basically a general idea of object-oriented languages. And examples of that would be Java, Python, PHP, C++. Your two common ones are Java and Python, and in this course we will be covering the object-oriented of Python. So you will get a little idea of what I mean further about these objects a little later on. Then you have functional languages. So these functional languages are again going to focus on functions. So remember, I just kind of briefly covered what a function is. It's like a grouping of a bunch of lines of codes that you can call one line to call 50 lines. And it basically is going to focus on that and its output. So it doesn't necessarily focus on the order of execution of the programming language. So again, it doesn't focus on the step-by-step process, but it more so just focuses on how the functions are called. So examples of that would be Haskell, F#, and Scala. Now, generally, these programming languages are not necessarily that common in the industry. They are still used, but they're just not as common. So you don't necessarily have to deep dive into these languages. If you're interested in programming languages, I would definitely say the ones that you want to deep dive into are going to be your object-oriented. You have scripting languages. So your scripting languages are going to pretty much be doing repetitive tasks, but these are generally going to be used with your web development. So HTML, JavaScript, CSS, stuff like that, all work together with the scripting. So as you see, JavaScript is there. It's pretty much used in web development. Lastly, we have our markup and query languages. So a markup language would be HTML, which we have covered. So that just gives you your structure. XML is another example of that. And then you have your query languages, and these are for databases to manage your data. So these are used to pretty much access, edit data and store data. So the most common one is SQL, and that is how you would create a database to store whatever information you need in like a website or your program. So now that we pretty much covered the programming languages, the programming language types, let's go ahead and see how code is in action. So again, just to refresh, your computer is going to understand your instructions based off of binary, so zeros and ones. So although you are writing in a programming language, that programming language is then translated into machine code using either the compiler or the interpreter, which we briefly covered in a previous video. Now, with your compiler, just know your compilers basically translate everything all at once, while your interpreters translate it line by line. So that is the difference between the two. Again, you can revisit a past video to know the difference between the two in further detail. But basically, you would write your programming language, they will be converted via a compiler or interpreter, and then it would be given to the computer as binary. So now that you know how code works and with the various languages, what are the building blocks of programming? So your building blocks of programming are going to be your variables, which are used to store data types. So that's basically looking at what type of data are you presenting to the program. So is it going to be text? Is it numbers? And then there's another data type called Boolean, which is basically just the value of true or false, literally. Boolean is considered true or false, just in only those two values. You have conditionals, which are used for decision making. So you can have in a program where you say, if this occurs, then do this. If that occurs, then do this. If this is equal to this, then we're going to do this. It's basically making a decision based off of what's happening in the code. You have loops. So loops are exactly what it sounds. They're used to repeat an action. So if there's something you want to do over and over again, you would use a loop. And your functions are going to be those reusable blocks of codes or containers, as I've just mentioned previously. So we will get a little deeper into these when we cover Python. So another good an important component of your programming languages is an algorithm. So algorithms are used when you are coding. This is basically the problem solving portion of programming or computer science that you hear referenced. So basically, an algorithm is just a step by step solution to a problem. So, for example, if you have a problem where you want to automate, doing some sort of process, you would make an algorithm that will break down step by step what you would have to do or what the computer would have to do to make that automation happen. So, this could be as simple as step 1, access this software, step 2, log in, step 3, access this data point, step 4, do this action to that data point, etc. So it's literally step by step, and you can reuse it over time with automations, for example. So now that we covered the important building blocks of programming, what is the role of a programmer? So you may hear that people say they are a programmer. And basically their job is just to solve problems using different logic or different decisions, using creativity in whatever programming language they choose to use. So you can design solutions. So that would be, designing algorithms, designing functions, and you would write and test that code. Now, the thing that makes it hard about being a programmer is, of course, you may think that you have wrote it correctly, but many times when you run it or test it out, it does not work as you thought it would. So you would need to fix and constantly improve the program. And or over time, the content you're using can change. So it would need to be fixed or edited so it would run. So being a programmer is not easy at all because it is pretty much a very tedious and iterative process where you have to constantly check to see if things are working or fixed or up to date. So it does add a little complication into things on that end. But it is rewarding once you finally solve it. So what I would like to say is programming or being a programmer is the equivalent of like being a problem solver or solving a puzzle. It may take a long time for you to complete the puzzle, but once you do, it's a satisfying feeling. So looking at programming in your everyday life, programming is basically in all technology. Every technology that you use pretty much has some sort of programming. But the most common areas you would see it is in your websites, which you saw with the HTML, apps, which also can be used or built by HTML. Um, you have your smart devices, so your watches, speakers, things of that nature, and even automations. So overall, we basically covered today what programming is, the programming languages that are out there and the different types that they are categorized in, and then we just learned your overall foundations of programming. So this is just a little insight into the world of a programmer or a software engineer or a software developer. And this is what they basically do for their career. And that is one of the big components of computer science. So now that you have an understanding of at least what programming is, we will deep dive into one specific language, which will be Python. So we will cover some basics in Python just so you all can see a programming language in action. And we'll test it out, see a few things, and then we'll continue our journey into the world of computer science. So until then, hopefully you found something interesting, and I will see you in the next video.